Welcome to Mr. Tompkins EdTech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers equations of a circle. I've taken related questions from my past paper walkthroughs and given them to you here back to back. These compilation videos will give you a deep dive on topics you are still finding challenging, giving you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Now in question 13 we're told that a circle has equation x squared plus y squared equals 4 and we're asked to find the circle radius. Now the equation of a circle centre origin is always of the form x squared plus y squared equals r squared, where r is the radius. So in this case r squared is going to be equal to 4, and if r squared is 4 that means r must be 2. In question 20 we're told that a circle has equation x squared plus y squared equals a quarter. Circle the length of its radius. Well, a circle centre origin has equation x squared plus y squared equals r squared, so that means that r squared should be equal to a quarter. So r is equal to the square root of that. Square root of a quarter is a half. So that's our value of r there. Question 25, the equation of the circle is x squared plus y squared equals 9. Work out the length of the diameter. Circle your answer. Okay, well this type of equation where you've got x squared plus y squared equals some number squared, that is the equation of a circle, and more in particular it's a circle centered on the origin. So it's going to be like that. So that is 0, 0 in the middle of your circle, and r, the radius, is well, you know, if it's x squared plus y squared equals r squared, then r is the radius of your circle. Now here, if I write what I was given, x squared plus y squared equals 9, you can see then that r squared must be 9, which means that r must be equal to 3. Okay, so the radius is 3. So what's the diameter of your circle? The diameter is all the way across. So it's going to be 3 and 3 makes 6, then, isn't it? It's going to be that one there. Question 20. Work out the diameter of a circle x squared plus y squared equals 64. Now, equations for circle through the origin are always of the form x squared plus y squared equals r squared. So that means that r squared must be 64, giving us a radius of 8. And if the radius is 8, then the diameter is going to be twice as big as that. It's going to be 16. Question 19. The equation of a circle is x squared plus y squared equals 11. Work out the length of the diameter. Right, well the equation of a circle is always of the form x squared plus y squared equals r squared. Okay, so comparing this, x, y, 11 r squared, we can see that r squared is equal to 11, and isn't it? So then r is going to be the root of 11. I don't see the root of, oh yeah, I do see the root of 11 there. There it is, okay. But that's the radius. I do see root 11 there. I was quite tempted to do that, but I would be wrong, wouldn't I? Because it actually asks for the diameter. Okay, it's in bold. Usually things in bold are things that students and teachers sometimes miss. So a diameter then is going to be twice the radius. So the diameter is going to be 2 lots of root 11. It's going to be that one there. Question 22. A circle centre O passes through 5, 0. What is the equation of the circle? Okay, so we've got the equation of the circle centered on the origin. Now you should know that the equation of a circle centered origin is the form x squared plus y squared equals r squared, where r is the radius. Okay, so the radius of this circle is that distance there, which must be 5, because that coordinate is 5, 0. So the equation of this circle is going to be x squared plus y squared equals 5 squared, which is 25, that one there. Question 17. What is the equation of a circle with centre 0, 0 and diameter 6 units? Okay, well, the equation of a circle is always in the form x squared plus y squared equals r squared for a circle centered on the origin. So we've been given the diameter here. So if we want the radius, we need to halve it. So x squared plus y squared is going to be 3 squared, which is 9. So it's going to be that one there. Which of these points lie on the circumference of a circle? X squared plus y squared equals 25. To find out if a point lies on the line, you've got to do is sub the values in and see if it's true. So is minus 3 squared plus 4 squared equal to 25? So minus 3 is 9, 4 squared is 16, 9 plus 25 is, so yes, 6.25, 6.25. So is 6.25 squared plus 6.25 squared equal to 25? 6.25 squared. Doesn't look like it. That's 39 by itself, so no, that one not. 9 and 16 is 9 squared plus 16 squared equal to 25. Well, I can already see that's much too big, so no. And minus 1 and 12, again 12 squared is 144 odd, so it's going to be too big, so not that one either. So it's just the minus 3 and 4. Right, question C. Circle true T or false F for each statement. The center of the circle x squared plus y squared equals 25 is 0, 0. Yep, that is true. The equation of the tangent of the circle x squared plus y squared equals 25 at the point of 5, 0 is y is equal to 5. Let's quickly just sketch that. So if I've got a circle centered on the origin and its radius is 5, because it's the square root of 25, then at the point 5, 0, the tangent looks like that. And is that the line y is equal to 5? No. That is the line x equals 5. So that is false. The equation of the circle and the equation of a straight line can have 0, 1 or 2 solutions if solved simultaneously. Yeah, they can, because either you've got a circle and a line which miss, or you can have a circle and a line that just touches it, so it's a tangent, or you can have a circle and a line spearing through it like that. So there are 2 points of intersection. So 0, 1 and 2. So that is totally true. Question 19. The point 5, 7 root 2 lies on the circumference of a circle centre 0, 0. Find the equation of the circle. Okay. So I'm just going to quickly sketch this. I'm going to cheat because I'm rubbish at drawing circles. There we go. So there's my circle. And then just draw some axes through it. 1, 2. Okay. So the center of this circle is at the origin. So that's the origin there, 0, 0. Okay. And we know a point on this line which is 5, 7 root 2. Now, where's the point 5, 7 root 2? Well, root 2 is bigger than 1, so something bigger than 1 times 7 is definitely going to be bigger than 5. So it's going to be like somewhere up here, isn't it? Okay, so slightly higher up than it is along. So that's the point 5, 7 root 2. I don't know how that's important, but I just like to get my diagram as good as possible. Okay, find the equation of the circle. Now, the equation of a circle-centered origin is always of the form x squared plus y squared equals r squared, where r is the radius of the circle. Now, the radius of the circle is this line here, isn't it? Okay, so basically to find the equation of this circle, all we really need to do is to find the length of that radius. Okay, now you could take this radius and you could turn it into a little right angle triangle like this, and then that triangle, okay, is going to have sides 5, which is the x coordinate, and 7 root 2, which is the y coordinate then, isn't it? Okay, so then basically what we're trying to do to find the radius is to find the longest side of a right angle triangle. So this is a job for Pythagoras theorem then, isn't it? So using Pythagoras theorem, then what we're going to do, the square on the hypotenuse, r squared, is equal to the sum of the squares of the other two sides. So it's going to be 5 squared plus, just going to do this in brackets because I'm going to have to do this in 2 parts, 7 root 2 all squared. Okay, 5 squared is easy enough, that's 25. 7 root 2 all squared, when you square something which has got 2 parts in it like that, that's the same thing as squaring each one separately. So it's going to be 7 squared times root 2 squared. So you're going to square both parts basically. Now 7 squared is 49. Root 2 squared is just 2. So I'm going to get 25 plus 49 times 2. 49 times 2, that's 98, isn't it? So I've got 25 plus 98, and 25 plus 98, that is 123. Okay? Now, I don't need to square root now to find r, because remember the form of the equation is x squared plus y squared equals r squared, and that's what I found. So there's no need for me to then square root this to find r, because actually what I was looking to do was find r squared so I can complete my my equation. So there's no need to do any further work. I'm just going to write down the equation now. X squared plus y squared equals r squared, which is 123. There we go, job done.
Question 21. In this question, all units are in centimetres. A circle has equation x squared plus y squared equals 36. Write down the radius and the centre of the circle. Okay, well, anything of the form x squared plus y squared equals r squared is going to be a circle centered on the origin of radius r. Okay, so the center of this circle is going to be 0, 0, and the radius, well, if x squared plus y squared equals r squared, and that's 36, then r is going to be the root of 36, it's going to be 6. So this is going to be a circle with radius 6 centered on the origin. Now part B says that the distinct points A, which have coordinates a comma root 11, and B with coordinates b comma root 11, lie on the circumference of the circle. Work out the length AB. So let's just draw a slightly bigger sketch so I can add some things onto this diagram. So here's my circle centered on the origin. Now it's got 2 points with height root 11, so they're going to be lying on a straight line, aren't they? So if you imagine a straight line passing through my circle at some point, it's obviously above the x-axis because it's positive, then one of those points is going to be the point A, isn't it? Let's say this one is on the left, and that's going to have coordinates a root 11, and then on the other side here I'm going to have B, which has coordinates b root 11. Okay, what do I want to do? I want to work out the length of that line AB. So I want to know how long that line is. Okay, well, how can I do that? Well, let's add some more lines in. I know that line, that's the radius of the circle, and I know that's length 6, and I know that one as well. That's also a radius of a circle, so that's also length 6, and I know the height of the line above the y of the x-axis is root 11. So I know quite a lot of things about this triangle. So what I think I'm going to do is I'm going to use Pythagoras theorem in one of the triangles. They're identical to each other, aren't they? They're mirror images. So one of these triangles, like this one, I mean, you're going to use Pythagoras in here to work out of the, you know, that top line there, and then I'm going to double it up to find the length as AB. Does that make sense? Let's just call that point there in the middle M, so I've got something to talk about. So, and that's O, it's the origin, and we said that was the point A. So let's have a look at triangle AOM. So in triangle AOM, we're going to be using Pythagoras theorem. So c squared equals a squared plus b squared, doesn't it? Okay, where c is the longest side, so rearranging it for one of the shorter sides, then a squared is going to be c squared minus b squared. So in other words, the line AM all squared is going to be the long side, 6 squared, minus the shorter side, root 11 squared. Okay, well, 6 squared is 36, root 11 squared is 11, so it's going to be 36 minus 11. Oh, it's 25. Look, that's nice. So then that means that AM is going to be the root of 25, which is equal to 5. Okay, so that one's 5. So this one is also going to be 5. So that means that AB is going to be 2 lots of 5 then, isn't it? So therefore AB is going to be 2 lots of 5, which is 10. Presumably centimetres, because it says all in centimetres. Okay, so AB is 10 centimetres.
Question 19. The point minus 5, 2 lies on the circumference of a circle, centre OO. Find the equation of the circle. Okay, I'm going to quickly draw this. I'm not excellent at drawing circles freehand, but no, that was quite appalling. Let's try that again. Okay, that one isn't too bad. And then I'm going to draw some axes. Now the centre of this circle is at the origin, so my axis is going to pass through the centre point of my circle. Like that. Okay, so my origin there is the point 0, 0. It's the centre of the circle. And I know that at the point minus 5, 2 lies on the circumference of the circle. So minus 5, 2 is going to be kind of over there somewhere, isn't it? Okay, that's going to be minus 5, 2. Okay, so I want to find the equation of the circle. Now the equation of any circle centered on the origin is going to be of the form x squared plus y squared equals r squared, where r is the radius of the circle. Now we can find the radius of this circle by finding this length here then, can't we? So if I find how long this line is here, that's going to be the radius, isn't it? Okay, and we can do that by just using the coordinates of that point. So we can then use Pythagoras theorem to find the length of the hypotenuse there. So this length, this triangle here, is going to be 5 by 2 then, isn't it? Okay, so using Pythagoras theorem, I can say that r squared, which is the hypotenuse, is going to be equal to 5 squared plus 2 squared. 5 squared is 25, 2 squared is 4. Add them together, it's going to give you 29. So r is going to be the root of 29 then, isn't it? Okay, so if r is root 29, or r squared is 29, then I can say, therefore, the equation of this circle is going to be x squared plus y squared equals r squared, where r squared is 29. So that is the equation of this circle. It's just as simple as that. Find the radius, stick it in that equation. Job done. Part B says work out the gradient of the tangent to the circle at negative 5, 2. Okay, so a tangent to the circle is a line just touching the circle at that point. So the gradient at minus 5, 2 would be this line here, wouldn't it? Okay, let's pick another colour. I choose U. purple. Okay. Oh no, didn't draw. Let's try that again. Okay. Now, drawing a sketch of your there's no drawings here, but quickly drawing a sketch is useful because it tells me information. It tells me that the gradient I'm looking for is negative because it's sloping down, and it's also going to be quite a large number, isn't it? It's going to be like -3, 4, something like that. Okay, so it tells me information which I can use to check my answer to see if it's sensible. Okay, now how am I going to find the gradient of that line? Well, we know that the tangent of a circle is always at right angles to the radius drawn at the point of contact. So I know that if this was the gradient, this was m2, then I know that it would be a -1 over m1, wouldn't I? I know that because m1 times m2 is always -1 for perpendicular lines, isn't it? Okay. Remember I said this was a shortcut for writing parallel. You can also write perpendicular like that as a kind of a right angle with AR written on the end. So for perpendicular lines, m1, m2 is -1. So if I can find the gradient of my radius, then I can use that to find the gradient of the tangent then, can't I? Okay, so let's do that first then. Gradient of radius is going to be well, it's going to be change in y divided by change in x, isn't it? So change in y is 2, and change in x is 5. So that's going to be 2/5. So gradient of tangent m2 is going to be -1 over m1, isn't it? Okay, so it's the negative reciprocal. So take my 2/5, flip it over, stick a minus sign in front of it. It's -5 over 2. Okay. Now I did say at the beginning that it's useful to have a sketch. Tells you extra information. I said that my gradient is going to be negative. It's going to be like 3 or 4. I've done it now, and it came out to be 5 divided by 2 is -3.5, isn't it? So yeah, I mean it told me a lot of things, and I can be confident now that my answer is probably correct. Now, if I hadn't drawn that sketch, I wouldn't be anywhere near as confident that I had the right answer. So always good to draw a sketch in a shape and space graphy question if you haven't got one. Question 27p is the point -1, 4. Okay, so that's -1, 4 on the circle, center origin. Work out the equation of the tangent to the circle at P. Give your answer in the form y equals mx plus c. Okay. Now, to find the equation of a straight line, we need 2 things. Either 2 points, which we don't have, or 1 point on the line and the gradient. Now, we've got a point on the line, but we don't have the gradient. So we're going to have to find out one of those bits of information from our diagram somehow. Now, in order to get that extra bit of information, we can use the fact that a radius of a circle is at 90 degrees to the tangent drawn at the point of contact. So my line OP is going to be perpendicular to my tangent. So if I can find the gradient of OP, then I can work out the gradient of the tangent. So let's find the gradient of OP first. So OP has obviously got the coordinate 0, 0 and -1, 4. So gradient of OP, which I'm going to call M1, is going to be my change in Y, which is 4 subtract 0, divided by my change in X, which is going to be -1 subtract 0, which is 4 over -1, which is a -4. So my gradient of OP is -4. Now, my gradient of my tangent is perpendicular. I'm going to call it M2, so that's going to be -1 over M1, isn't it, for perpendicular lines? In other words, it's going to be negative 1 over negative 4, which is 1/4. So my gradient is going to be 1/4. So the equation of tangent is of the form y equals 1/4 of x plus c, where c is the y-intercept. Now we know that the line passes through the given point, which had coordinates -1, 4. So if we sub those two into the equation, so we know that 4 then is going to be equal to 1/4 of -1 plus c. So now we can work out what c is. So 4 equals a negative 1/4 plus c. So take that negative 1/4 to the other side. So c is 4 1/4. So then our equation of our line is going to be y equals m, which is 1/4, x plus the y-intercept, which is 4 1/4. Question 28. P is a point on the circle with the equation x squared plus y squared is 80. P has an x coordinate of 4 and is below the x-axis. Okay, so we know that that is 4 comma something. I'm just going to call it 4y for now. Okay, work out the equation of the tangent to the circle at P. Okay, so we need to find the equation of this line. Now, in order to find the equation of a line, we need to know two things. Either the one point on the line and its gradient, or we need to know 2 points on the line. Now, at the moment, we've got part of one coordinate. We know that the x coordinate is 4. Now, we should be able to use the equation of the circle to find this value here of y. We're just subbing x into it, and we'll work out what the value of y is. So that will give us 1 point on the line. Now, how are we going to find the second point or the gradient? Well, if I draw this line in, which is the radius of the circle, oops, then you should know from the properties of a circle that a radius joins a tangent at 90 degrees. So we do know 2 points on this line. We know that that one is 0, 0. And once we find y, we'll have a second point on this line. So that is enough information to find the gradient of the radius drawn at the point of contact. And then we can use the fact that that radius and this tangent are perpendicular to find the tangent gradient. And then we should be able to find its equation. So quite long, but let's just crack on and let's get it done. So the first thing we need to know is that y coordinate of P. So at P, when x equals 4, then y then is going to be, well, the equation of the circle is x squared plus y squared is equal to 80 then, isn't it? So we're going to get 4 squared plus y squared equals 80. So 4 squared is 16. So then y squared then is going to be 80 minus 16. It's going to be 64, giving you values of y as plus or minus 8. So if we have a look at our graph, you can see actually there are going to be 2 points on this curve. You're going to have one up here, which is going to be at 4, and that's going to be the plus 8. And then this one down here then is going to be minus 8 then, isn't it? Okay, so we've got our point on our line, 1 point on our yellow line, 4 minus 8, so we're getting there. So the next thing then is to find the gradient of our radius. So this line here, let's find the gradient of that. Now we know 2 points on that. We've got 0, 0, and now we've got the point 4 minus 8. So we could easily find the gradient of that. So on the line OP,
it's a good idea to put little sentences explaining what you're doing. So our gradient m, we'll call it m1 because we're going to have two gradients. Our gradient m1 is going to be, do you know the formula for it? It's y2 minus y1 over x2 minus x1, where x1, y1 is your first coordinate and x2, y2 is your second coordinate. So my first coordinate, x1, y1, is going to be this one up here, and this is going to be my x2, y2. Okay, so subbing that in carefully, I'm going to get y2, which is minus 8, subtract 0, divided by x2, which is 4, subtract 0, is what then? So negative 8 divided by 4, which gives me a gradient of negative 2. So my line OP, my radius, has a gradient of negative 2. And I'm going to call this point up here T, so I can refer to it as PT. So OP and PT are perpendicular. It's a shortcut of way of writing perpendicular. It's like a perpendicular sign with AR written on the end. So OP and PT are perpendicular. So M2, the gradient of our line PT, is going to be minus 1 over M1, which is the negative reciprocal of negative 2, which is positive a half. So that tells me that the gradient of my tangent then is going to be a half. So tangent PT is of the form then y is equal to a half x plus c, because I know the gradient now is a half. All I need to do now is to find the y-intercept, and to find the y-intercept I could just sub in my point that I know. I know that it passes through the point 4 minus 8, so subbing that into the equation, so minus 8 then is going to be equal to a half of 4 plus c. Okay, well a half of 4 is 2, and subtracting 2 from both sides will tell me that c is equal to negative 10. Okay, so then my equation of my tangent is going to be y is a half x subtract 10, because I just found c was 10. And that's it. So it's quite a long question, but the skills you should all know fully well: how to sub into an equation, finding the gradient of the line, knowing that two lines are perpendicular to each other, how to find the gradient, and then finding the equation of a line given a gradient and a point on the line. Okay, all done. Question 19. The diagram shows circle x squared plus y squared equals 5. Mandy says that the point 2, 1.5 lies inside the circle. Is she correct? Okay, you must show how you decide. Okay, so we've got this point 2, 1.5. You know, I'm going to draw it there, but it might not be on the inside of the circle. Okay, now to work out if it's on the inside of the circle, the easiest way of doing it is to work out how far away it is from the center. Okay, now if we can work out this distance from the center to the point, we can then compare it to the radius of the circle, which we should know. What is the radius of this circle? Well, we can derive, or we can work out from this number here. The equation of a circle centre origin is always the form x squared plus y squared equals r squared. Okay, so r squared, the radius squared in this case, is 5, which means the radius of our circle is going to be the root of 5. Okay, so we know that this distance here is root 5. So if we then find the distance between the origin 0, 0 and our point x, which is the point 2, 1.5, if we find the length of that line and it's greater than root 5, then we know it lies outside the circle.
If it's less than root 5, we know it's on the inside of the circle. Okay, so we just need to use a bit of Pythagoras theorem here, work out that distance, and then use Pythagoras theorem to find the length. Okay, so I know that this value here is 2 and this one is 1.5. I get that from the coordinates. So then 2 squared plus 1.5 squared all square rooted. What's that then? So the length O, let's call it point A, length OA squared is equal to 2 squared plus 1.5 squared using Pythagoras theorem. 2 squared is 4, 1.5 squared, well 1.5 is 3 over 2, square it is 9 over 4, isn't it? Okay, so what's that then? 4 plus 9 over 4. Well, 9 over 4 is 2.2 and a quarter, isn't it? So that's 6 and a quarter. So I can see already it's lying outside the circle because I'm comparing this 6 and a quarter with my root 5. So this, remember, this is the length squared. So this is bigger than 5, isn't it? So therefore it's going to lie outside the circle. So OA squared is greater than R squared. Okay, and therefore it lies outside the circle. Okay, part B says the tangent to the circle at the point -2, 1 intersects the y-axis at A. Show that the area of the triangle APO is 5 units squared. So P is -2, 1. So that is -2, 1. And what do we want? We need the triangle APO. APO. So from P to O, let's just draw that line in. Let's just draw this triangle actually. So we want this triangle that comes from here and then from O to A, and then A back to P again. Okay, what sort of triangle is it? Can you see? Now OP is the radius of this circle, isn't it? And a radius and a tangent join at the point of contact are always at a right angle. So this is a right angle triangle. We already know OP. We know it must be the radius of the triangle. It must be root 5. Okay. So to find the area of this circle, basically what we need to do is to find the length AP then, isn't it? So if I can find this length here, then I've got the two sides of the triangle. I can multiply them together and divide by 2 to find the area then, can't I? Okay, so I just need to find the length AP. Okay, so let's find the length AP. So we've got this, got this, got this, got a right angle here, that's root 5, that's P, that's A, that is -2, 1. What's the coordinate of A? We just need the coordinates of A then, don't we? Do we know what that point there is? Well, we know that the x coordinate is 0. We don't know the y coordinate yet though, do we? Okay, now can we find that? I think what we're going to have to do is we're going to have to find the equation of the line AP, aren't we? If we know the equation of the line, then we'll know what the y-intercept is, because it will be the c value of that equation, won't it? Okay, so what I want is the equation of the line AP. Okay, now in order to find the equation of the line, I need either 2 points on the line, which I don't have because I don't have the point A, or I need the 1 point, which I have, and the gradient. Now I don't know the gradient of the line AP just yet, but I do, or I could work out the gradient of OP, and I can use the fact that that is perpendicular to the gradient that I want to then find out what the gradient of AP is. Okay, So we're going to find the gradient of OP first. So O is the point 0, 0, isn't it? So the gradient of OP, let's call it M1, that's going to be the change in Y. So Y2 minus Y1. So let's call this X1, Y1, and this X2, Y2. So the gradient is change in Y, Y2 minus Y1 over X2 minus X1. So that is Y2, which is 1, minus 0, divided by X2, minus 2, subtract 0. So that's going to be negative a half then, isn't it? So that equals minus a half. Okay, so then the gradient of AP is going to be negative reciprocal of that then, isn't it? So you flip it over and you change the sign, so it's going to have a gradient of 2. Okay, so we know the gradient of this line AP, and we know a point that it goes through, minus 2, 1. So equation of the form y equals 2x plus some unknown value c, which we're going to find. So we know it's the form y equals 2x plus c because we know the gradient is 2. So then subbing in the point that we know, so let's substitute the point in, minus 2, 1 into equation. And that's going to give me 1 is equal to 2 lots of minus 2 plus c then, isn't it? So 1 equals minus 4 plus c, so c then is going to be 5. Okay, so now I know 5. So we know this has equation y equals 2c plus 5. Now that 5 is the y-intercept then, isn't it? Okay, so that means my value up here for a is now known. We now know it is 5. We found it. Okay, now we know that value. We're making some progress. So now we can work out the length AP. And once we know the length AP, we can work out the area. Have we got some more paper? They give us a lot of space to work this out, do they? Okay, we're running out of space down here. I'm going to go back up here and do some working up here, I think. So we've now worked out that this point up here is 0, 5. We want to work out the length of this line here, don't we? Okay. So we're going to use Pythagoras theorem using the coordinates of P and A to work it out. Okay. So if we call this one x1, y1, x2, y2, then I have an equation of the length of the line. So the length AP squared is equal to change in y squared, so y2 minus y1 all squared, plus change in x all squared, x2 minus x1 all squared. We're just applying Pythagoras theorem to the coordinates, aren't we? So y2 minus y1, that's going to be 5 subtract 1, so 5 subtract 1 all squared, plus change in x, so we're going from minus 2 to 0, so 0 subtract 2, 0 subtract negative 2 all squared. Okay, so that's going to give me 4 squared plus 2 squared, so 16 plus 4, that's 20, so that's root 20. So AP is root 20. Okay, so we now know that length of AP is root 20. So we know both sides. We've got root 20 and root 5. So we should then be able to work out the area of the triangle. So coming back to here, we can squeeze it in here. Area of triangle. So that we said was root 20 and root 5. So area is equal to a half base height, which is a half
times root 5 times root 20. So what's that? Root 5 times root 20 is a root 100. So half root 100. Root 100 is 10. Half of 10 is 5. Okay, well that was a lot of work, but we got there in the end, and it was worth 6 marks. So the area of the triangle APO is 5 units. Okay, so we did it. Hurrah and huzzah. Question 27. In this question, all lengths are in centimetres. A is a point on a circle centre O. B is a point on a different circle centre O. And AB, we are told, is 20. Okay, so here's the diagram. So they haven't marked that 20, have they? AB. That's this line here, isn't it? So we're told that that's equal to 20. Okay, now we're told that the equation of the larger circle is x squared plus y squared equals 144, and the radius of the smaller circle to the radius of the larger circle is in the ratio of 4 to 5. Okay, what's the question? Still not seen the question. Oh, here it is on the other side. Work out the size of angle AOB. So that's what we need to do. Work out the angle AOB. So AOB, so we're talking about this angle here, aren't we? That's the angle that we want. Let's call it theta for now. What is that angle? Okay. Well, we don't know, do we? Let's have a look at the information we've got down here. We've been given the equation of the larger circle. X squared plus y squared equals 144. Now, the equation of any circle centered on the origin is of the form x squared plus y squared equals r squared. In other words, the radius squared of this circle then is going to be equal to 144, meaning that the radius is going to be the root of 144, which is 12, isn't it? So that means that this distance here, O to B, is 12. Okay? We know the radius of the smaller circle to the radius of the larger circle is in the ratio of 4 to 5. So 4 to 5. If we know that the radius of the larger circle then is 12, what is the radius of the smaller circle? Using the unitary method, going via 1. So if I take 5 and I divide it by 5, I'll get 1. If I then times it by 12, I get 12. So if I do that to the other side, 4 divided by 5 and then times by 12, I should get my radius then of the smaller circle. So that is going to be 4 divided by 5 times by 12. That's 9.6. So then the radius of the smaller circle then is 9.6 centimeters. So coming back to my diagram, that's this side here, isn't it? So that's 9.6. Okay, so I've got a non-right-angled triangle. I know all 3 sides and I want to find the angle. Do you know what to do there? It's the cosine rule, isn't it? So we're going to be using the cosine rule here. So in the cosine rule it says, well, let's just write down the cosine rule and then see where we are. So the cosine rule says a squared equals b squared plus c squared. It starts off a little bit like the Pythagoras theorem, minus 2bc cos a. That's the general form of it, isn't it? Okay, so here, so if you know the 3 sides and you want the angle, you need to make cos a the subject of this. So I'm going to rearrange it. So I'm going to make cos a the subject. So taking this bit and added it to the other side, or added it to both sides, and then subtracting a squared so it appears on the other side, I'm going to get 2bc cos a equals b squared plus c squared minus a squared. And then dividing both sides by 2bc, I'm going to get cos a equals b squared plus c squared minus a squared all over
2BC. Okay? Now, when you're using the cosine rule and you're labeling up sides, you label opposite sides to using the same letter as their angle. So from my diagram here, if I said that was, I said theta earlier, if I make it A, then this must be side A here. It doesn't really matter about the other two. So that could be B and that could be C. Okay, so but A has to be the 20. The other two, it doesn't really matter. So let's sub those in then. So we're going to put in A is 20, B is 9.6, C is 12. So A is 20, B is 9.6, C is 12. I'm going to sub that into this formula and then work it out. So that's going to be equal to B squared, 9.6 squared, plus C squared, 12 squared, minus A squared, 20 squared, all divided by 2 times 9.6 times 12. Okay. So what's that? We can put all that into the calculator, can't we? So 9.6 squared plus 12 squared minus 20 squared divided by 2 times 9.6 times 12. Now that comes out to be a negative number, minus 0.7111. Lots of ones. I'm just going to write down the first couple. But it's a cosine, so we want A, don't we? So we want to find the inverse cosine of that then, don't we? So A is going to be the inverse cosine of minus 0.711. What's that then? So shift cos answer. Now that comes out to be 135.3 degrees. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.